This conference will now be recorded.
So I am waiting a couple of minutes because there still seem to be people getting on. If anybody's having technical issues, there is somebody who can help you whose information is in the chat box. Well, the dings have started slowing down, and we have about 80 some participants. So I want to welcome everybody to the second webinar sponsored by the HAB Observing Group. I want to remind you that this webinar is being recorded. Next slide. The agenda for this meeting is a brief overview, and then we're going to have 3 presentations, and Clarissa will introduce the speakers, and we're going to ask them to stick very strictly to the time limits so that there's plenty of time for discussion in the Q&A. And in fact, the discussion has already started in some of the practice sessions. And then we'll have a brief wrap up and a schedule for future webinars. Next slide. So I just want to remind everybody, both the people who were here the last time and any new participants, of the purpose of the HAB Observing Group. This is an informal coalition whose primary purpose is to enhance scientific collaboration and to allow information and resource gathering. We hope this HAB user group will inform and be informed about the development of the National HAB Observing Network, or NHABON, as we call it. The membership is open to anyone with an interest and will be guided by the participants so that it provides a forum to share information and lessons learned. We hope it will provide connectivity and synergy between regional, national, and even international HAB observing efforts. We're starting out with quarterly webinars with what we hope will be robust discussion afterwards. As time goes on, we would like to involve more people in leadership and deciding what activities will be most beneficial to promote a HAB observing community. Next slide. Ultimately, the strength and success of the HAB Observing Group will depend on the contributions of its members. Now I'll turn it over to Clarissa to introduce today's webinar.
Thanks, Quay. So I will turn your attention to the topic of the day, which is data tools, emerging approaches for thinking about how we deal with just the incredible number of sensors and methods that we have as a community to gather the information we need, do the monitoring, translate that into prediction and forecasts. And then, of course, within just that complexity alone, there's so much regional complexity in terms of biology, the needs. It's kind of an endless and complex problem, as you all know. As we're thinking through this, it becomes more and more clear that we need new ways to think about the data architecture, the tools, the end-to-end life cycle of how data then gets into the hands of users and what that looks like when it happens. We all think about these problems, but I think as more and more of us get involved, that harmonization of those protocols is becoming more crucial. And so we want to really think about that today, and what kinds of tools could be put in place so that people are not starting from scratch, reinventing the wheel every time they acquire, let's say, an imaging flow cytobot, or start to think about how they might approach community science endeavors. We have lessons learned. We have a lot of ways to share this information, and thinking through the data part of that and the visualizations that are involved is kind of one step to getting there. So today we're going to showcase a few of those tools that are aimed at harmonizing approaches and converging those technical resources. And then we'll probably, at the end, we'll summarize some of that and think about how we do have a long-term goal as we have future webinars to discuss as a community what those data products should look like, how they should be produced, and how we can adequately integrate them to meet all of the management and monitoring needs that we have in the nation. So now, next slide, I'm going to introduce our speakers for the day. We've got Rob Bohenick. He has over 20 years experience providing cyber infrastructure and data management support for oceanographic observation systems and monitoring programs. We have the pleasure of working with him at SCOOS. He is the CEO of Axiom Data Science, which he started in 2006, but before that, he was the data management team lead at the Exxon Valdez Oil Spill Trustee Council, overseeing a $30 billion research portfolio, monitoring the physical and ecological trends of the spill affected area. And then now, as many of you know, Axiom currently provides core cyber infrastructure for many ocean observation programs. So it's not just within IUCE, but this includes NSF's Ocean Observatory Initiative, the IUCE RAs, SOCORA, SCOOS, CENCUS, and AUCE, DARPA's Ocean of Things program, and the Office of Naval Research's Animal Telemetry Network, that's the ATN network, and the list goes on. Today he's going to describe how we might go about creating a national HAB data assembly center, what kind of efforts are involved to make something like that happen. And then next we have Mike Brosnahan. It's a pleasure to have him here. He's an assistant scientist at the Woods Hole Oceanographic Institution and leads several projects aimed at developing HAB observing systems in New England and elsewhere. I'm sure many of you know him well. Today he'll be sharing some of his team's work to develop a new data sharing tool called HAB Hub. And then last, certainly not least, we've got Bob Currier. He's a research specialist with the Department of Oceanography at Texas A&M University. And his primary area of expertise is ocean observation, data management, and visualization, working for years with GCOOS. Currier is the developer of HabScope, which we'll hear about today, an automated filing and classification tool that uses AI, artificial intelligence, to detect and count Karenia brevis cells. And then Halo, which is a real-time data portal for HAB studies of Lake Okeechobee, and Gandalf, a real-time data portal for autonomous underwater vehicle operators. So without further ado, as they say, I will now turn this over to Rob. And I should actually put questions till the end. Sorry, I meant to say that too.
Hi everyone, I'm calling in from Anchorage, Alaska. The sun just came up and it's like -5 out. So looking forward to summertime. Next slide, please. So summary of today's talk, I'm going to give a quick introduction to our project, provide the context for phase 1 of the project, which is the California IFCB network, show a quick example of improving an IFCB data processing workflow, like a scientific workflow through enhanced cyber infrastructure, and in essence, operationalizing this scientific workflow. And then I'm going to do a quick demonstration of the Harmful Algal Bloom Data Assembly Center, the HABDAC. Next slide, please. So this Harmful Algal Bloom Community Technology Accelerator is being led by Clarissa Anderson, who's on the call today, myself, Heidi Sosek, and Stace Ballou out of HUI, Rafe Cadella in the Cadella Lab, and Henry Rule out of CENCUS. Our specific objectives are to stand up a transition advisory committee to provide some guidance and scoping, provide cyber infrastructure for the California IFCB network and all of the new data feeds being produced by those, and then plan for, ingest, and curate additional harmful algal bloom data types and operational harmful algal bloom forecast products and nowcast biophysical modeling systems into the HABDAC itself. And then we want to centralize and assess and optimize machine learning models and training data sets that are used by groups right now pretty much in isolation. We want to see cross-work, co-development, standardization of these toolkits, and more broader community adoption. And then we ultimately want to develop a transition plan to support the transfer of the technology to other groups. Next slide, please. So we are trying to accomplish some pretty lofty goals while simultaneously having some tractable deliverables. So when the rubber hits the road, we're really here trying to stand up this California regional hub for harmful algal bloom data. And then once we've done that, we want to expand it out to a broader kind of level. And in year one, we're going to stand up this transition advisory committee. We're going to establish the harmful, the HABDAC, the Harmful Algal Bloom Data Assembly Center. And then using the HABDAC infrastructure, we're going to support the California IFCB network. Year two, we're going to convene a workshop to help kind of drive requirements for our system. We're going to continue to centralize and curate additional HAB data sets. So these could be ESPs, other IFCBs, other data products, shipboard measurements, precursors to HAB blooms, a variety of different data. We're also going to centralize and optimize a variety of different machine learning models and training data sets that are kind of being used by individual groups across the nation and world and the broader community. And we're going to deploy a HAB resource catalog to help users who want to find and ingest and utilize HAB data and HAB resources, get that in their hands faster. In year three, we're going to continue to do some of the same things we did in year one, year two, and we're going to try to converge upon and promote a standard data architecture at a national level through broad implementation of the HABDAC and HAB resource catalog. And then ultimately identify more permanent funding sources to operationalize this approach, and then get other interest partners there. Next slide, please. So this is phase one work. This is the California IFCB network design, and there's a variety of different sampling of IFCBs, shipboard measurements, a whole slew of different HAB measurements. And we're looking to support this at a regional scale, and by developing the techniques here, we can scale up. Next slide. This is an example of using cyber infrastructure to operationalize like a scientific workflow. So as many of you are aware, machine learning models are used to classify a lot of these phytoplankton images that are produced by various instrumentation. And we've been able to use working with science teams, our data scientists at Axiom Data Science have been able to use more advanced deep convolutional neural networks and other machine learning models to produce more highly efficient classification schemes and models. And so we've also been able to migrate these things to operational workflows, meaning like move these things out of being run in batches and actually being run operationalized on infrastructure that's being monitored, and machines are doing all the work and it's in real time. Next slide, please. So this is an example of an older kind of workflow, and we've migrated these to more of an optimized, automated, operationalized workflow. Next slide, which is this one, the new method. Next slide. So this is the Harmful Algal Bloom Data Assembly Center. I did a pre-screen video. We're going to run it right now. I would implore everyone on this call to check out the HABDAC. There's a feedback button up in the upper right-hand corner. So if you interact with it, you find some data, you want to provide some feedback, you know of any information that you'd like to see in the HABDAC or any additional data feeds, please submit some feedback through that upper red tab in the HABDAC portal. So go to the video now, please. So this is the landing page for the Harmful Algal Bloom Data Assembly Center. And here's where we showcase some various types of data we think are high priority for the HAB network in California. The HABDAC has a data catalog and an integrated map. And the integrated map allows you to choose and overlay a variety of different numerical modeling data, HAB observations, physical observations, and those types of things. Right now, we're jumping into the HABDAC catalog itself, And you can see we have a variety of different data which are relevant to harmful algal bloom forecasting and inputs into models and such. So here's like one of the entries in the HAB. This is IFCB deployments in California. And this is like a metadata record. This is a layer that can then be added to the integrated map. Also, we can search for information. So say we wanted to look for Clarissa Anderson's CHARM model. And this is a harmful algal bloom forecast or a nowcast product that's produced out of UCSD. And this is a gridded product, time series. So this data is being ingested into the HABDAC cyber infrastructure and being curated and brought up to kind of IUCE data standards. And then by doing this, we're able to easily visualize the data and integrate the data with other sources of information. And we can add this data to a map. Did that video freeze?
No, it didn't. I see it's still going.
Okay. That layer's been added to the map. What you're looking at right now is a hexagon grid that is capturing all of the real-time sensor observations and then overlaying that with a harmful algal bloom, the CHARM nowcast. So
Rob, you have 1 minute left, just FYI.
Yep. We can kill out this the sensors here and do an extraction of time series. You can roll over and see what the probability of a cellular domoic acid higher than 10 picograms per cell. And if you were to click on this numerical model, you would extract out a time series that you could then look at historical trends at that location. So build kind of like a seasonal average or a weekly historical average over the 3 years we have this model and see how current predictions for probability of cellular domoic acid compare to historical averages.
Okay, Rob, time to wrap up.
Okay, and the video is it's going to jump to the IFCB network, but if we need to kill this video, we can. There's probably another like 45 seconds.
Yeah, I think we need to kill it. Kill it, Maggie. I don't want to kill it. We got to kill it. All right. Thanks, Rob. So I guess we'll wrap up and we'll move on to Mike and then circle back for questions later. It was great. All right, Mike.
Yeah, thanks, Clarissa. Yeah, so I'm going to tell you about our HabHub project. There's several of us working on this. It's an open source web-based tool for visualizing and sharing HAB data. Next slide, please. This is part of a larger project where many of us have been working towards establishing a observing network for HABs in the Northeast US. You can see some of the partners here. Next slide. We have a long history in our part of the country of PSP that's caused by blooms of Alexandrium in the spring and summer, but more recently we've seen a diversification of our HABs with new toxin syndromes and fish-killing species really occurring year-round. So next slide. And we've been trying to meet this challenge through our deployments of Imaging Flow Cytobot, or IFCB, and Environmental Sample Processor, or ESP, sensors. So the IFCB is an automated light microscope that we deploy in situ. It streams images of individual phytoplankton cells continuously in deployments that can last up to 6 months. So really large data streams there. And then with the ESP, we're mainly using it for sensing of domoic acid produced by Cyrenaica blooms. Next slide. These sensors are being installed at some previously established time series locations and also have hotspots. Next slide. And in the past year, we've started to use a couple of new mobile and semi-mobile platforms. So we have the C-Track autonomous surface vehicle that allows us to put the IFCB offshore. And then we have these barges that support the IFCB, ESP, and a profiling CTD, and we can bounce them between different locations along the coast. Next slide. So we're producing a lot of data, and from that data, we're deriving some different products. So for instance, from our time series of HAB cell concentrations, we're trying to predict shellfish toxicity. And we needed a tool to bring all of this data together along with a lot of our partners and other colleagues in the region who are producing other really helpful data. So we have a product that can really provide the best possible situational awareness. And so that's sort of our foremost goal with the HabHub project. We're trying to automate ingestion of data into this system and build something that can really serve a wide range of audiences, from lay people to Hab scientists. The project is open source, so to promote adoption and adaptation by other groups. And we're trying to sort of bake in some ways to facilitate data reuse and sharing. Next slide. The software is built using the Docker system, so it's containerized. It can run on basically any hardware. It can run on laptops. It can run on the cloud. It has a Postgres back end, and then we use Facebook React Java for a map-based UI front end. Next slide. One thing just to note also is that it's not a standalone product. It's actually part of a constellation of web content that we've been developing as part of these projects. The first one to roll out was the Northeast Hab page, and that provides a lot of background information that's more specific to our region. HabHub has been the second one that we've brought online. That's still really in a developmental state. And so, just like Rob said, we're really anxious and welcome any feedback when you have a chance to interact with the site. We have a couple other sites that are more focused on data analysts and collectors. Those will be coming online next year, and those are really focused on documenting things like our SOPs and sort of how we produce the data. All of these websites are reference one another and link to each other, and also the National Hab Office harmful algae page, which is another great resource for Hab information. Next slide. So just like Rob, I've got a little demo here. This is the Northeast Hab page. You can see there's some links there for the organisms that are impacting our region. There's also some background on past and ongoing research and some really nice educational content that Mary Curran and Mindy Richland have been putting together that targets primary, secondary, and special needs classrooms. So really a wealth of information and sort of resources here. Jumping now to the HabHub. Again, this is really intended to serve a wide range of audiences. It has sort of a weather map feel. You don't have to be terribly sophisticated to glean some really valuable information from it. You can select and deselect different species. There's different data layers here. So our IFCB cell concentrations are represented by these glyphs, and the relative size of those polygons at those stations reflect the relative abundance of these different species. Shellfish bed closures are marked in orange. You'll see those toggle on and off here momentarily. And then shellfish toxicity are in the diamonds. I think this is going to hop now to the next tab. Yep, so now focused mainly on our Alexandrium data. So we have a long history of that kind of data. We can actually manipulate what years we want to look at, and all of that is propagated up into the map as you play with these menus. We can look at either the maximum or minimum, so you can see the shellfish toxicities in the diamonds or changing intensity with that. We can also sub-select intervals within the year. So if we want to see the summertime when we have peak PSP, there you go, it's pretty hot there. We can exclude that and then look at the winter, and you see PSP risk generally is much lower in the winter time. So this is just a way to sort of hash the data and really take fully access all of the resources that are available. Zooming in now to Cape Cod Bay, and specifically the Nauset Marsh system, which is an area that I do a lot of work. You can see that's the Nauset Marsh system there. You can click on any of these elements in the map. And so right now you're looking at closure data. You can link out to a notice that the state actually issued that details all of that tabulated data that you saw in the prior page. You can close that out and click on our shellfish toxicities and get a time series there. That graph that you see can be exported in a variety of formats, or we can export the data itself in a CSV format directly off of this plot. And finally, if you click on the glyph, we can see the IFCB data. We can refine the time interval. You can actually click on the plot, and when you do, it's going to bring up some of the images in this case that were classified as Alexandrium, and so you can review all of those and also click out to our dashboard so you can see some of the other types of phytoplankton and particles that were in the water at the same time. So the IFCB is producing this incredibly rich data set, and we're just sort of showing the HAB component of that through the HabHub. So I showed you how we can export CSV data. That's part of a larger sort of aim to make this data as accessible as possible. And so a real nice early success there is our work with Dan Ward. He's a grower near us. He grows scallops and oysters, and he's been really heavily impacted by these Margoliphididium blooms. We were able to get some funding. He has an IFCB now at his farm, and that IFCB actually pings our server and looks to see when the Margoliphididium exceed a certain threshold. His IFCB then initiates contact, so it'll send out emails and text messages to us to let us know that there's a problem, and then takes the further action to shut down pumps at his nursery to really limit the exposure of his animals to these blooms. And so he was able to prototype this really quickly using data that he was accessing through the HabHub without having to sort of learn all the sort of coding skills that are more typical right now. Next slide. So that's what I have to share today. We've got also this roadmap to a lot of work that's ongoing right now and in progress to update the UI, including a new user guide and tutorial, some updates to our cell concentration layer, and we're planning some new layers for the coming year to share ESP measurements on some of our sensor-driven prediction of shellfish toxicity. Next slide. So just to wrap up, please go ahead and visit any of these sites. The HabHub is at habhub.hui.edu, Northeast Hab is at northeasthab.hui.edu, and then some, but not all of the folks who are contributing to these projects. Thanks.
Thanks, Mike. Excellent. Okay, next speaker, Bob Courier. Bob, you are on.
All right. Yep. Thanks. Had to unmute. I'm going to talk this afternoon about HAB Forecast and the HAB Scope, which are community science-driven tools for HAB awareness. The PIs on this project are Rick Stump from NOAA and Barb Kirkpatrick. And on the left, you have a view of the HAB Forecast page during a recent bloom event in the Sarasota and Tampa Bay area. And on the right is Dr. Mike Allen from the Cedar Key Marine Lab, University of Florida. And Mike just received one of the first HabScope 2.0s a couple of weeks ago. Next slide, please. So the HAB forecast, and the URL is up there on the top, and this is being recorded, so you should be able to find it, is the public-facing site for the NOAA HAB respiratory forecast model. We ingest the NOAA model every 3 hours and then create a respiratory forecast for each site, and it's automated. There's not a list of predefined sites. So if the site is in the model, then it gets a marker on the map, and it's a 30-hour forecast with 3-hour intervals with the respiratory irritation classified from none to very low to moderate to high. We just rolled out a Spanish language version a few weeks ago. And this site has been designed from the beginning to be mobile friendly. And as it turns out, Google Analytics says that about 85% of our traffic is mobile. It's been pretty popular, 235,000 hits this year, which is a pretty good number for a science resource site. The inputs to the model come from the HabScope AI cell counts. We also do manual counts from the various state and county agencies that participate in the program. So all of this goes up into a data tank in Rick Stump's shop, and then his modeling team takes that, pulls in the National Weather Service weather data and coastline orientation, and then spits the model out, which we then visualize. Next slide, please. So we've got a lot of good press. I won't go into this. You can Google the news, HAB forecast and HabScope, and pull this up. It's gotten a lot of attention in the local media. Probably the best article is down here at the bottom. I love the title. The hunt for red tide relies upon AI and retirees. And I am going to, if I can get it to go out, let's see. There we go. I put a link in the chat channel to a very recent in-depth article from a journalist in Sarasota that provided some excellent insight into this. Next slide, please. So this is HabScope 1.0. We use an iPod with a 3D printed microscope adapter. All the 3D components were engineered by Gary Kirkpatrick. We take 30-second videos. They get uploaded to the cloud, DigitalOcean server. The videos are analyzed by AI. It's TensorFlow and Keras and a custom CNN model that I designed. 1.0 takes about 4 minutes to analyze the video. We've got a reasonably modest quality on the video, as you can see from the picture on the right. But we're able to get an R-squared of about 0.92. And if you want the nitty-gritty details, we have a paper in PLOS One. You can just Google HabScope and PLOS One, and it comes right out. So again, looking at the left on the image of the HabScope One, you can see we've got a pretty small screen on that iPod, and most of our volunteers are retirees, so we did have some issues with visibility and screen size. Next slide, please. So that was HabScope One. Now I'm going to tease you with HabScope 2, which has much better resolution, and the video is playing. This is a live image from HabScope 2 at 400x of a Corynea cell using an optical staining algorithm that I developed so that the cellular features stand out without having to use Lugol's or anything like that and kill the cell. But if you watch, you can see the flagellum moving. You can see water particles moving by. And this gives you a good idea of the capability of HabScope 2. And keep in mind that this is a $500 system. And video's up. So next slide, please. So this is HabScope 2.0. It's a Raspberry Pi 4.0 with 2 gigs of memory. We use a 14 megapixel Raspberry Pi camera with a C-mount and a microscope adapter. So HabScope 1 is afocally coupled. The eyepiece is in the scope. HabScope 2 goes directly into the microscope with no eyepiece. Right now, we've got 3 models, one for Corynea, one for Pyridinium, and one for Alexandrium. We are working on expanding that library with training. We also have what I call the survey mode that allows the users to collect raw videos. They get uploaded to the cloud just like everything else, but they don't get analyzed. This is intended for K through 12 programs that just want to get build an archive of the microbiodiversity of their area, as well as to collect samples that we may want to develop models for later. HabScope 2 takes 4 seconds to analyze the video instead of 4 minutes, and the annotated image is then pushed back to the user, so the volunteer gets immediate feedback in terms of the number of cells that were classified. You don't need internet to record the videos or operate this, and you don't need the internet for the AI. Right now, everything is run on the cloud, but this supports Google Coral, so it's designed to be able to go out on a ship where there's no internet connection and to run for a week or 2 weeks, hands off, and provide the PIs with real-time classifications. And again, $500 per HabScope. So that's the key thing. That price point lets us get this out in large quantities and really saturate the area. The output does feed the NOAA Hab forecast, and in recognition of what we're all trying to do and the reason for this webinar today and the great work that Mike and Rob have done, soon the HabScope output will generate NetCDFs, and that'll go into the GCOOS ERDAP infrastructure so that the Hab Hub and the HabDAC and other resources can reach out and ingest an IU certified NetCDF with the metadata, the analysis, and the raw video, so it can be used elsewhere, and it's not just localized to HabScope. Next slide, please. So these are 3 images of the results. The slide on the left is what the volunteer, or the image on the top left is what the volunteer gets. That's at 40x, which is what we usually run at because we need a pretty wide field of view. The green markers are AI positive for Corynea. The red are things that it was interested in but decided weren't Corynea. Yes, there's a lot of Corynea cells that have a red square, but that's early on the training of the model, and so it gets progressively better. On the right, that's HabScope running at 100x, and you can see the really detailed images that you get as well as the optical staining kicking in with the yellowing of the cell. And the bottom image is Alexandrium at 40x. And again, you can see the quality of resolution that we're getting out of this. And while it might not be quite up to IFCB standards for a $500 instrument, that's pretty good resolution. Next slide, please. So all of this goes to our HabScope data portal, and two NOAA analysts watch everything. We have a human in the loop. So the videos go in with a timestamp, the Sentinel. The analysts look at it and decide if it was over or underestimated. They approve it. They can go in and edit down at the bottom, change the status, change the location, and then finally, if it's really off, they can put in a manual cell count and then update the record. So we always want the human in the loop before we deliver public health data to the public. Next slide, please. So to get involved, our volunteer coordinator is Grant Craig, and that's Grant down at the bottom, helping us deliver the HabScope to Cedar Key. His email is in here, and again, it's being recorded. We're going to deliver 40 HabScopes to our volunteers over the next few months and get them converted. We've got 10 going to, I'm on the last slide. Yep. To Alaska. And next slide. Next slide. And that's it. And just a special thanks to IUs for the pilot project funding and NCAUS, MERHAB for the additional funding, without which we wouldn't have been able to do this.
Thanks. Sorry to cut you off. Wanted to make sure we have time for questions. It looks like we're going to have ample time for that. This has been really cool hearing about all these different things. I hope you sort of realize that while each one of the talks we just heard does right now have a regional focus, there's a lot of capacity within each one to extend into a national framework for data assembly. And I think that we can really imagine how we can have these flexible approaches where one really helps us even get past some of the, I think the previous limitations we had with things like community science, where we couldn't rely on untrained members of the community to do this kind of microscopy. It's really quite fascinating. I'm going to open the floor. I know there have been a few questions in the chat, and I'll loop back to those, but let's, feel free to jump in. When you have a question, you can just turn your camera and your mic on and let us know who you want to direct the question to. See a few cameras coming on.
Do we just speak up if we have a question?
Absolutely, just speak up, and I'll patrol the chat as well.
Okay, cool. So I guess I'll introduce myself. I'm Jill Flieger from the Florida Department of Agriculture, specifically the Division of Aquaculture, and we are responsible for opening and closing the aquaculture farms and also the wild resources. And so this is more for the HabScope. What is the lowest count that the newer HabScope is capable of detecting? Because we close our areas at 5,000 cells. And I know when this was being developed, it could only think the lowest limit was 50,000. So I was just wondering if that's improved over the last few years.
The lower limit is still 50,000 right now, simply because we don't stain and we don't concentrate. So detecting cells in an unconcentrated sample below that is tough. I think we can do it. Certainly something that we're working towards, but for right now, I think we're sticking with 50,000.
Okay. Yeah, I think we could, it would be useful in some applications that we do, just some alternative strategies for our HAB management. So I'll probably be reaching out soon about maybe potentially getting a HabScope in our Shellfish Center in Apalachicola.
Yeah, thanks for that question. I see there's one in the chat for everybody, which addresses the kinds of data formats that we would want for the interoperability of the systems that were presented today. I know that Bob ended with the nice point that when you have things in a NetCDF file, particularly with the kind of correct metadata standards and format, you can get that easily into ERDAP, which is then one way, for instance, that Axiom would be able to pull it very readily, as was mentioned. So that's one important format. Not all data are going to be presented to us that way. So I'll let any one of you guys want to address this. You want to jump in? Rob, maybe.
Yeah, I mean, I can. I can add to that.
Thanks.
I think that a lot of this harmful algal bloom, it's really like, in essence, phytoplankton biodiversity measurements. I know we're looking for densities of, specific organisms, but when you're dealing with the data on a level, at a primary level, it's going to be kind of these counts of organisms at places and locations. Of course, we all produce like secondary and tertiary products beyond that. I mean, NetCDF is really awesome for physical data, but maybe we could, of course, you can put NetCDF, anything in a NetCDF, but this could also be stored, I believe, in like more Darwin core, and also just a really structured kind of data format that may even be simpler than NetCDF. I mean, we can use NetCDF, but there are other options here. I'd like to hear a little bit about, I mean, I'm assuming that everyone else has got their own, they've got a database, they've got a spreadsheet. That's probably what other groups who are boots on the ground. I mean, what Bob has got going on, he's got this end-to-end system, but Bob, you're just storing that stuff in a database, correct?
Yeah, right now it's a Docker stack and it's a MongoDB database.
Right. So I don't know if you could throw ERDAP on top of Mongo if there's like a SQL, anyways. But I'm not going to get into details. I think more importantly is just getting this stuff exposed. If you're comfortable exposing it, especially, or maybe even putting it on somewhat of a embargo, be like, okay, I'm not going to release data for 4 weeks, but just getting access to historical data is going to aid in everyone's ability to develop improved products and systems and tech. So NetCDF is great, but I think there might be easier ways to get data sharing happening quicker than all of us trying to converge upon a NetCDF format.
Yeah, good point. And since I still have you on the line, Rob, so Sophie Clayton wants to know, I don't know how well, sorry, hold on, you guys know Ecotaxa, but I think we need to think about, you mentioned this in your talk, but we're working on this in our world with this PCM Hub project, which is the coordinating of image sharing, building image libraries, thinking how we can train and have menus of different kinds of classifiers. Maybe elaborate a little bit more on that for Sophie and how that might look a lot like Ecotaxa in the end.
Yeah, and we are looking for the best path forward for community sharing of imagery and community-based annotation tools. So Ecotaxa is on our list for assessment, and we're also looking at, there's a system out of Hui that's being developed. They're on their version 2 for an annotation system. It's not completely in the SOSIC lab, I don't think. Maybe Clarissa, you could talk a little bit more about it, but we're looking at a way to get all of these images in one place that maybe we have some control on security or partitioning, but it'd be much better if it was just openly available, but just attributed to various sources. But then we want groups coming in and collectively annotating these things. And there may be differing opinions, and there's maybe differing levels of street cred when it comes to annotation and things like that. So that's what we're looking at. And I know that Ecotaxa has advanced significantly in the past couple years, and so I'd like to learn a little bit more about that platform too, as a potential option.
Yeah, so I just add on to that, Rob, and kind of going back to the previous question, especially with the IFCB, also with the HabScope, the primary data is really valuable, and the identification of Hab cells isn't sort of the end of the story. So the idea of having digital records of these and capturing the images and archiving them is really powerful for all of us to kind of go back and recognize patterns that maybe we don't see immediately, or to sort of look back in time and identify trends and introductions of organisms and this sort of thing. So that's another consideration for future data systems and sort of ways to ingest and share in standardized formats, not just for the IFCB, but for all of these other imaging tools.
Mike, do you want to address Jonathan's question? This is a good one since we spent a year kind of trying to average these kinds of costs, but basically the cost of getting, deploying, maintaining an IFCB, which can vary, of course, depending on where you are and how you're deploying it. But
yeah, I think there's a big learning curve that you can get invoiced. I think they're about $140K right now from McLean to purchase an instrument. You can kind of think of it as getting an employee, because that system is you probably will have to have an employee to sort of maintain the system, but if you have a fleet of them, that cost goes down. The IFCB is really a system that automates sampling, and it doesn't foul. So we can, like I said, we can put it out for months at a time. So it is expensive, but it does produce a data product that's got some really powerful capabilities associated with it.
good answer. It's a nice range when you move from HabScope to IFCB of options, but they have trade-offs. Ellen Prager, I see your comment. I don't know if you want to jump in and maybe talk to us about your project that you'd like people to get involved in. And that's fine if you don't. I see your message in the chat.
So can you hear me? I've just have my mic on now.
Yeah, we can hear you.
Okay. Hi. Yeah, this is Ellen Prager. I'm a marine scientist, and I've been working with Storm Center Communications that worked with NASA and NOAA to develop what's called GeoCollaborate, and it can take different formats of data from hubs and portals and websites, and has created a collaboration interface so that you can use it in a couple ways. You can have a leader, follower, so you can have a subject matter expert do a session where you have a leader and as many followers you want, and it puts everybody on the same map at the same time, and you can manipulate the data, and the leader can turn on different data sets, and so that all the followers get those data sets and can inquire on it. And so it's a great way to do briefings, to communicate to the public, and then it also creates a dashboard afterwards. But we are working with the Indian River Lagoon folks to showcase how this might be able to be used with HABs. And so we're doing a first demonstration December 6th, and I put a link to register. We're going to be doing several more of those demonstrations, but it doesn't replace the portals because we recognize everybody's investing so much time and energy in creating these great portals. And it was really great to see the ones that were showcased here. What it does is it creates a new interface that can take the data, identify where it comes from, and allows you to showcase that data in a collaborative way that isn't really possible with like data sharing or just the portal itself. So we'd love to get other groups engaged and just to see what you think and how it might be able to work with your portal or hub.
Yeah, no, thanks for bringing this up. And I'm sure many of us on this call will want to pitch in. I don't have a huge amount to add to that. If anybody on the panel wants to jump in, feel free, and then we'll move on to another question. Greg, I know you're here. We were thinking you might want to tackle Brian's question regarding, there was a number of questions about inland HABs, but let's think about how flexible we can make these to ingest and deal with inland HAB, freshwater HABs. Greg, you see the question I'm referring to? Maybe Greg ran off. Well, I know, Mike, you've mentioned that you've done some freshwater work with the HAB Hub. Can you tell us how that transpired?
Yeah, so we have a project with Singapore. Singapore has a lot of reservoirs and desalination plants, so they're really interested in water monitoring. They use an IFCB for some of that work. And so we built a version of the Hab Hub to present their data. In that version of the Hab Hub, we actually identify over 200 different, or no, it's more like 150, I think, actually, taxa. And the user has the ability to select which taxa they want to see plotted. Those glyphs have a limit to about 6 species that can be presented at one time, but it maps across the city of Singapore with the different reservoirs, and it works pretty well. So, I mean, the simple answer is that there's no limitation to marine systems. It can be used for any type of water monitoring.
Excellent. Thanks, Mike. Anybody else want to jump in with a question? I'm going to continue to pull things out of the chat if not.
Yeah, Clarissa, let me touch on the freshwater real quick. I've gotten a couple of emails about the freshwater, and we've certainly thought about it with HabScope. Rick Stump is deeply interested in the blue-green, so it's not limited to saltwater specifically. We've actually had interest in everything from Zika mosquito larvae to microplastics, just because it's a multi-purpose instrument in there. But right now our focus is on the marine Hab, so just because we're so resource constrained.
Thanks. I was going to jump in and answer Carol's question. I was just starting to write it in the chat. It looks like Mike may have answered you. Yeah, we'll always be constrained, I think, with the microscopy for Pseudonychia. As Mike points out, we can do kind of rough size classes, but unless you're pairing it with toxin measurements or an ESP doing the toxin measurements, I think it'll always be tricky to not have false alarms with respect to Pseudonychia blooms. Does that help answer the question, Carol? Yes, okay, good. All right, what else we got here? I know I'm probably skipping over people I don't mean to. Anybody else want to just jump in verbally before we wrap up?
Well, I had a question. This is
Go on,
Quay. My camera's not on. I'm not sure why it's not coming on. Anyway, the question that I had is, obviously, since I am from NOAA and am interested in the whole question of where do we go from here, if the short-term goal is to harmonize approaches and converging resources, what would each of you tell NOAA is the next step they need to take? Is it more funding for research, a workshop for more focused community discussion, doing a Hab pilot project on the data itself as opposed to a regional pilot project? What do you think is the next step? And any of you can jump in and answer that.
I think I think a workshop, getting certainly our groups, and there's several others around the country that are doing really important work in this area. Just getting us all together, talking about sort of what the vision is for a system that sort of captures and archives, not just IFCBs and HabScopes, but all sorts of data, and makes it available in ways that everyone can access. I think that'll be really powerful. And then sort of kind of dividing up some of the other tasks. Rob had a lot of really important comments about, capturing sort of the provenance of annotations. So when a researcher gets out there and uses their expertise to identify cells in some of these samples, sort of capturing that, making it a data product that they can share and get credit for, and have it be accessible sort of widely, I think will be really powerful. And then I don't think any of this needs to constrain development of sort of regionally focused kind of last mile systems that sort of share this information. So we could have, there might be some future national system that, someone could use to visualize HABs across the country, but there's nothing precluding the development of other systems that are more focused on specific user groups. And all these things sort of require some conversations and sort of particular focus, I think. And a workshop is a great way to sort of start that process, my opinion.
So either of the others want to chime in on that question?
Yeah, I think I would just like to comment that the three systems that have been presented here really do dovetail with each other. There's some common overlap, but it's these systems are not in conflict with each other. I think HAB Hub is an awesome tool for a regional understanding of like what is the state of harmful algal blooms. The HAB Scope is really like boots on the ground. Like, I'm really impressed with the pragmatic engineering that's been done from the instrumentation up through the low-level management of integrating these feeds and curating these feeds and getting them into the system. It's like the HAB Hub, I mean, the HAB DAC that we're operating, we could either feed a system like HAB Hub, or we would consume from a system like HAB Scope. And I think, I think HAB Hub has a potential to like expand and develop into a more mature product that can be regionally deployed to 25 locations around the nation. And HAB Scope could probably be deployed too, and at other regions. So I think like forcing us to go into the sandbox together and work, be like we can. This isn't really that big of we have overlaps in the right places with data and but our purposes are really like we're isolated from each other. And I think there's other groups that need to be part of this conversation too, obviously.
Yeah, that was going to be my next question to you, but it sounds like you're thinking about it. Bob,
Yeah.
do you have anything to add? We're running out of time, but I'll give you the last word if you.
Was that me?
Yeah.
Okay. No, I agree completely with Rob, and we've kept that in mind in the design of HABscope 2.0. The intent was always to provide a product that was useful to the scientists and the larger science community, as well as the public, and keep focus on that and do it in a shareable way. So absolutely. As we take these things down the road, thinking about that as we design new products is going to be really important. But I'm encouraged by everything I've heard from Rob and Mike today. I think we're really starting to head in the right direction.
It was a nice way to sum it up. And Greg, we see you. We see that you're on mute. Sorry about that. Thanks for writing in the chat. So Quay, I think we can move to your final slide.
Well, so the next webinar is going to be March 2nd, 2021, and it's going to be Making Community Science Work. We've also scheduled the May 4th webinar, but haven't settled on a topic yet. So next slide. Thank you all for attending. We hope this has been a useful discussion, and we'd like to continue this discussion. This is a really important topic for HAB observing. So until the next webinar, we'll be seeing you later.
Thanks everyone for attending and for all the great questions. Of course,